That's gonna be.
You'll check the function, it's a math attack. Adding up numbers, never looking back. Fractions, decimals, keeping it tight.
All right, let's pretend you're doing this for the very first time. Everyone say, draw a line. Let's draw a line down our equal sign. I do that to separate the left and the right side. Put your fingers on the two that are like terms. Show your partner. Have your partner give you a head nod. These two are like terms. They are friends. They are lovers. How do we get them back together? Pay attention. If I go this way, then I have everyone on the left side of the river, and that's not too great. But if I go this way, they're going to be on the same side of the river. So let's subtract 2x. Class, what's 2x minus 2x? I have nothing here, so you just bring it down. Class, what is 6 minus 2? 4x. What math operation is between 4 and x? Multiplication, so the opposite is division. 4 divided by 4 is 1. And we're left with 12 divided by 4 is? Whoops. 3. Raise your hand if you got 3. All right. Diana, what do you think we should do first? What do you get? Oh. Outcome. Here? Remember, this is a what number? So think about it as 2 minus 1. Yeah, that's just plus x equals 9x plus 6. Here, you're just combining like terms. All right. Isaac, what should we do next?
You should get rid of the x on the left side and add it to the right. Minus 1.
How do I move this x to the other side?
Well, I mean, just like x.
Negative x. So you can think of that as a 1. So the opposite of positive is a negative. Isaac, can you tell us what's left?
12 equals 8x plus 6.
So what we're doing here is we're getting the like terms together across the equal sign. Pay attention, here's a big idea. When you combine like terms, you don't do the opposites. When you're on one side of the equation, all you have to do is just add or subtract. When you move it across the equation, across the orange line, that's when you're doing opposites. Okay? Thank you, Isaac. Gene, what should we do next? Gene? Subtract 6. She's getting the constants together. Gene, what's left? Thank you. Sarah, what should we do next?
Divide 8.
Divide by 8. There's multiplication. The opposite is division. Raphael, what's left?
Divide. Reduce.
Reduce what? What do you get? What are the factors of 6?
2.
And the factors of 8? Can you simplify anything there, Raphael?
2.
And what are you left with?
3/4.
Raise your hand if you got x equals 3/4. So big idea, simplify on one side if you can. We're trying to get the like terms together. So the x's are together, the constants or just the numbers together. When you go across the line, you do opposites or inverses.
Let's solve linear equations doing Mr. Ng's way. The first thing I want you to do is draw a line down the equal sign. What are you drawing? You got to know the river, the line, when you're crossing it or not. And our goal is to get our friends together. My friends are the variables and the constants. Those are without variables. We have to get them together to make them happy. We're trying to get x by itself. X is, I guess, an introvert, just wants to be by themselves. Okay, someone tell me what they did. Shout it out. Yeah, just shout it out. Subtract 2 from both sides. Let me write that down. Class, show me thumbs up, thumbs down. Can you do that? He is correct. Look. You want to move something, this 2 to the -8, yes? And to go across, we just read it, you have to do the opposites or inverses. So the opposite of positive is negative. Now, did you see how I wrote the -2 below the -8? I did not do it in the middle. I did not do it on the left. Okay? Everyone say not like terms. They're not friends, right? You might have Yu-Gi-Oh! And Pokemon. Are those the same? You can't combine the two decks. Okay? These are like terms. Okay. Someone tell me else what else we can do. That's one way of starting the problem. Subtract x from 3x. Thumbs up, thumbs down. Can we do that? Yeah. You see in math, it's kind of like choose your own adventure in this way. Someone else, tell me something you can do. Did you see how they're opposites? Sorry, let me point that out. This is a positive, and that's a negative. We're okay? Someone said add 8. Can we add 8 to both sides? Yeah. Where do I put the 8? Under the 2. Let's go from here. This is a good start. I'm super happy. Okay, now we're just going to go down. Gravity is down. This one goes down. 3x. Class, what's -8 plus 8? 0. I don't have to write it. In this case, canceling equals 0. What do I do with the x? Down. 2 plus 8. 10. Partner A, tell partner B, what did we just do here to start the problem? And B, tell A, what do you think is the next step? Ready, set, go. Melissa, what do you want to do next? She says subtract 10. Subtract the x. Yeah, I want to get those x's together. So if I subtracted 10 and I went over here, I'm kind of introducing someone who doesn't belong in the group. They don't look like it, smell, dress alike, the hair. Does that make sense? So this one over here, they're saying opposite, 1x. Or positive 1x, we're going to subtract 1x. Class, tell me what's left on the left side. 2x. Did you notice how I'm only subtracting the coefficients here, the numbers in front? The x stays the same. And on the right side? we have 10. X is almost by itself. Partner B, tell partner A, what's the relationship between 2 and X? Go. Now, the other person, tell them what is the opposite of what you guys just saw. John, what is the relationship between 2 and X? What is in between here, John? Addition, subtraction, multiplication, or division? Multiplication. John, what is the opposite of multiplication? Correct. So we're going to do what? Divide by 2 on both sides. This is called division property of equality, which you guys read. Class, what's 2 divided by 2? 1. So now I'm just left with the X on the left side. And 10 divided by 2 is 5. How does X equal 5 mean that it's balanced? If you put in 5 here for X, on the right side, that would be 5 plus 2, which would be 7. If you put it on the left side, 3 times 5 is 15. 15 minus 8 is 7. 7 equals 7. That is balanced or equal. All right, for question number 12, before we do that, a couple of hints here. Always try to move the smaller variable. So we'll move this one over that direction. That's what I'm talking about. Combine like terms. So these have x's, and then these without x's, those are constants, those are like terms. And then the last one is when you're going across that yellow line there, or the equal sign, make sure you do opposites. Remember, the opposites are actually done by PEMDAS, but you're actually going from the bottom to top, okay? Let's go ahead and try this. So I want to move the smaller variable over, and when I want to go across the equal sign, so it's a blob, that's positive, so it's going to be a negative 3x. Now, I'm not going to put it underneath here. That's a no, not a x. Because they're not like terms. So I'm going to put over here. 5 minus 3 is 2x. This one just comes down. That equals 0. And then we have the plus 4. Okay, so now I'm going to get the constants together. So I'm going to add 2. Because I see and then I do the opposite. So I get 2x equals 6. And then I see multiplication, so I just have to divide it by 2 on both sides. X equals 3. Remember, you can always take that, put it back in there. To check your answer, you would get 5 times 3 minus 2, which is 15 minus 2, which is 13. And 3 times 3 plus 4, that would give us 9 plus 4, which is 13, and that is true. Say it again. All right, let's go over this problem. I want you to think in your head what I'm about to do. Talk to your partner what I did right here. Class, show me with your thumbs. Yes, you can do that. No, you cannot. Show me your thumbs. Yeah. You are breaking the laws of math. Thank you. Put your hands down. And so this is a common mistake. Because I would say that these are what? These are not like terms. Do this. I did that on purpose. Now, what can we do? Subtract 5 from 4. So do you want me to, oh, you want to do minus, but let's think ahead. If I do minus, what would happen to my answer? It'd be negative. Let's try this way. If I add 4, Class, how can I get those x's together? Are we going to add or subtract? These are opposites. Six x?
Yeah.
Class, what do I do next?
Divide.
Divide. Uh-oh. I don't divide by 9. Divide by 6. This is going to be 3 times 3, 3 times 2. And so you're going to get x equals 3 halves. Raise your hand if you got x equals 3 halves.
We love math A, we love math A, we love math A. Every time we divide, we already know the path A. Then we multiply, all we gotta do is roll the die A.
John, what do we do first? Yeah, what do you get, John? Good. Keep going, John. Tell me what to write. Good. Raise your hand if you got what John got. Yeah. All right. Lori. Left side or right side? Sorry, I'm back here. Okay, what do you want to do? What did you say? Subtract? Add, multiply? What do you want to do? What did she say? Sorry. Subtract 3. Did you mean subtract? Subtract 3x. There you go. All right. Class, what are we left with? 3x plus 2 equals -7. Okay, this might look a little bit different, but we'll get the same answer. Angel N, what do we do next? Subtract 2. So notice we're not touching that variable yet. Same Angel, what do I get? And then Christina, what do we do next? Divide by 3. X is equal to what number? Christina. X equals -3. If you didn't know, you can take x equals -3 and put it back up here to see if it actually makes sense. 4 times -3 is -12. 2 times -3 is -6. -12 minus 6 plus 2 is -16. And 3 times -3 is -9. Minus 7 is -16. So that's a 6. That's equal. Do you see how I can check my answer too?
Okay guys, I'm gonna give you guys free time to do your work. I've been trying to do my work, but I just can't seem to get this right. I see what you're doing wrong. You're not doing the operations the PEMDAS right. You keep dividing first and not multiplying first. Oh my gosh, I realize that now. Thank you. Thou shalt honor the correct order of operations. That's what Mr. Ang always says. Thank you.